Business Intelligence lecture. Today is the 30th of October 2025. So we continue today with our deep learning by hand concepts, and today we will look at one concept that is very important called convolution. Okay, basically the intuition is as described in this image. Okay, so we have one image and we want to extract, for instance, the edges of the toy there and the different furnitures. Okay, so in order to extract this information from the image, we perform something called convolution. And it's a standard procedure, and we will look at this today. So convolution is a technique used in image processing okay, is the process of summing and multiplying each element of the input image with its local neighbors. Okay. The convolution uses filters to extract the relevant information we are interested in. Okay, these filters have a name and are called kernels. Okay, kernel is a German word meaning core. Comes from algebra. A kernel has different meanings in information technology, in IT. Okay, can mean different things, but in this case, of image processing, a matrix is a matrix that shapes the weights of the convolution. Okay, so this is the intuition of what a convolution is. Okay, mathematically, maybe you have seen this already. F convoluting to G applied to x might be interpreted as f applied to g of x, okay, depending on the notation. It's just applying one function to another, okay. But what are we doing in image processing? We are doing processing of images. Okay, so image processing is the most visual example. That's why we do it. We can do it with other domains, but image processing is the easiest. But what is the domain? What is an image? Okay, that might seem like a crazy question, but first, before we start saying what we do, let's try to understand what an image is. Okay, so we have this image. From this image, we take, let's say, a portion, like one little square of the image, like the face of the puppet. We take it and let me crop it. Okay, like for instance that. Okay, I mean it's not exactly, but you get the concept. So I'll make it bigger so that I can make my point. And the thing is that what you see here is, I mean, this is just the thing made bigger. What you see here is something that you probably already know intuitively. Probably, maybe you've heard of it. Something called pixels. Okay. So if we look at this, we see little tiny points. Okay. You see? You know what a pixel is, right? So what this is, each one of these pixels are in reality 3 values, okay? Because we have 3 channels on a color, so each pixel color pixel has 3 channels. Red, green, and blue. Okay? So in reality, what we are having is we're having something like this. We have a superposition of 3 channels, each one with their pixels. Okay, one red, one green, and one blue. Put the R above. That's why we talk about RGB channels. Okay. So each channel, each value can be between 0 and 255. Okay. So each pixel is therefore represented by 3 values. For instance, 37, 13, 210. Okay? Each pixel. The reason why we have 256 values is because of the structure of the data. Okay, so 1 byte has 8 so-called bits. Okay, so each byte has 8 bits, and each bit can be either 0 or 1. Okay, so the combination of 2 possibilities in 8 different positions equals 256. Okay, that's the reason why, so that you have heard it. So one image is a bunch of pixels. Each pixel has 3 values. Okay, so like let's say we take like the 3 values R, G, and B for each pixel, and we get then the 3, 37, 13, and 210 for each pixel. All right. Is this clear? You should give me thumbs up or thumbs down or ask questions, whatever you want. Yep, Sebastian, Vicente, Iker. What about the rest? Emre, good. What about the rest? No more? Okay. Maybe they're taking a coffee. So with this input, with this intuition, let's say this is an intuition. This is not like the real thing yet. Now we define some kernels. Okay. Um, so kernels can have many shapes and sizes. Okay. It can be used, kernels can be used for attention, for blurring, like if you want to pixelate some parts of the image, can be used for edge recognition, just in the example above. You see here, we are just recognizing the edges of the image, right? So this is edge recognition. So how do we do this with math? Okay. So like let's learn how to do this with math. So for edge recognition, we can have this shape. Let's say I'm just going to give you examples. Okay, this is just a huge deal of different possibilities. So I'll just give you 3 or 4 examples, and then if you're interested, you can dive into it more. Let's say here, duplicate. So here is an example of a edge recognition where we're looking at corners. Okay, so 1 minus 1, 0, 0, 0, 0, 0, minus 1, 1. Okay, this is an edge recognition. Why? Because only the edges are non-zero. Okay, so this is edge recognition. We can also look at an attention kernel. Okay. Good. Let's see how an attention kernel looks like. As I said, this is just examples, and I'll do just 3 by 3. In the real world, this is way more complicated. Okay. This is basically the technology used by your iPhone when we are recognizing, when the iPhone recognizes your face. This is what the iPhone does. So when we're looking at an attention kernel, it's exactly the opposite. The corners are 0, and we highlight the center because we have an attention kernel. And all the rest is made negative. This would be an attention kernel. Okay? The middle is highlighted. It's made 4 times bigger. Okay. Is that cool? Can you follow? How many people do we have online actually? Just 5 people online on the well, that's right. Whatever. All right, so let's see with an example how this looks like with let's say numbers. Okay. Example. I'll just take this. No, wait. No, I'm gonna take like one image. Same again. I'll crop it. And yeah, let's use this image. A little example, okay? And let's imagine we find out what are the values of each pixel. This is done with simple Python function. And we have this channel R. For channel green and blue would be exactly the same, okay? So I will not do the whole, I'll just do the channel red and with dummy numbers. Not gonna do the real. This is done with the computer then. Okay, I just want to explain the concept. 2, 1, 1, 0, I don't know, 1, 2, 1, 1, and 1, 2, 2, 1, 0. Okay, so this is going to be our red like pixels, and then we have an attention kernel. Which could be something like this. Let's say 3 by 3. Zero, minus 1, 0, minus 1, 4, minus 1, 0, minus 1, 0. Okay, so let's see how this works. What we do is we create a convolution. And we need to say what is the step of the convolution. We call this convolution step stride. You'll see in a second what this means. So stride is going to be 1. Okay, so what do? We take let me put this with another color like that. Okay, so we take a window in the original image like this. Okay, 3 by 3. and we multiply this window with the kernel, so by elements. So we take the window 110, 121, 0, 1, 2, and then we convolute this window with the kernel. Okay, we convolve the window with the kernel. So you see the elements here. 110 is 110. Okay, I just copied 112, 112, 012, 012, and the kernel 0 minus 1 0, and so on. Okay, so as a result of this multiplication, so I just need to do the element-wise multiplication, okay, which is 1 times 0, 1 times 0, plus 1 time minus 1, 1 time minus 1, plus 0 times 0. Okay, you see, it's just multiplying elements, plus 1 time minus 1, plus 2 times 4, plus 1 time minus 1, plus 0 times 0, plus 1 time minus 1, plus 2 times 0. Okay? And this gives us one number. If we do it real quick, minus 1, minus 2, plus 8, 6, minus 1 is 5, minus 1 is 4. This delivers 4. So our convoluted first element is going to be so the convoluted red layer is going to be here a square, which is going to be 3 by 3. The first element is going to be 4. This goes here. Okay? Does it make sense? This is not a 0, it's a convolution, okay? Just like when we did the convolution here. All right, so now pay attention, okay? Is this clear? Yes? So now we move. Now please pay attention, okay? We move the window, and this is convolution, okay? This is the stride number 1. We move the window 1 element, 1 pixel, okay? That's why it's stride number 1. If we would have stride 2, we would move the window 2 times, 2 pixels. Okay, so we move the window, and we say, now we have 102, 102, 211, 121. Then the same kernel 0 minus 1 0 minus 1 4 minus 1 0 minus 1 0, and then we do the same, just multiplying 1 times 0 plus 0 times minus 1 plus 2 times 0 plus 2 times minus 1 plus 4 times 1 plus 1 times minus 1 plus 1 times 0 plus 2 times minus 1 plus 1 times 0. This delivers 4 minus 2, 2 minus 1, 1 minus 2 minus 1. Okay, so I insert here minus 1. And then it just repeats. Okay. I move again 1 pixel. I'll do the third one just for the record. 0 to 1. 1, 1, 0. 2, 1, 1. Convoluted with the filter. 0 minus 1, 0, minus 1, 4, minus 1, 0, minus 1, 0. This delivers 0 times 0 plus 2, 2 times minus 1 plus 1 times 0 plus 1 times minus 1 plus 4 times 1 plus 0 times minus 1 plus 2 times 0 plus 1 times minus 1 plus 1 times 0. This delivers minus 2, minus 3, plus 1, minus 1, 0. Okay? And the rest is just the same. You can do it on your own. That now we would move. I'll do another one. We will move again here. Okay. So our new window is 1, 2, 1, 0, 1, 2, 1, 2, 2, 0, minus 1, 0, minus 1, 4, minus 1, 0, minus 1, 0. Then we say it's 1 times 0 plus 2 times minus 1 plus 1 times 0 plus 0 times minus 1 plus 4 times 1 plus 2 times minus 1 plus 1 times 0 plus 2 times minus 1 plus 2 times 0. Minus 2 plus 2, 0, minus 2. Okay, so minus 2. The solution is going to be a 2 by 3. Okay, convoluted image. Then we would move again, and so on. Okay, so you can do that. This is just not rocket science. All right. Questions? Any questions? So there's a question here. Is this the same technology that driverless cars use? Of course, yeah. Anything that is image recognition is this technology. It's deep learning applied to image processing. Okay? Exactly this. Just basically made with GPUs. Your PlayStation is a GPU, it's a graphic process unit, basically. Processes graphics super fast or multiplies matrices super fast, just like we do here, okay? So anything that has to do with images is just matrix multiplication. just super fast and very effective. For that, we use C++, C++ in the background of Python. Okay, so now there's one thing also that it's important here. It's called padding, okay? Padding. Here, the concept of padding. So in order not to lose information, on the edges of the image, we can pad the image with zeros, okay? And in order to do so, we just get the, before multiplying with the kernel, before doing the convolution, we say, okay, this is our image. Let's say a 1, 2, 1, -1, 0, 1, 1, -1, 2 image. Before multiplying with the kernel, we say, okay, we add padding. In this example, equals p equals 1. So what we do is we add one layer of zeros all around the image. So basically, we are not adding any information to the image, but when we do the convolution, we will start here, okay? So this pixel, which was in the corner, which might have been left out with an attention kernel, is now taken care of. So in the exam, I can give you this and this, and say stride is 2, padding is 2, do me the convolution of the image, okay? And so you start to, you need to know what stride means, what padding means, and you need to implement it. I totally recommend that you give yourself one exercise like this with different numbers, and you do that, okay? Any questions? Yeah, if p equal 2, then you get this two rows, and like this is p equal 2. Okay? So, and so on. Just depends, okay? Just adding zeros does not add information, so you can do it. The goal is that when you do the convolution with With an attention kernel, for instance, you don't lose the edges. That one doesn't get lost anymore. Okay? So this is padding 1. All right? So before I continue, I am noticing right now that there are only 4 people or 5 people online, okay? I don't know why. It's your decision. I guess you are online, so you are the false addressees for this. Maybe you want to talk to your fellow students. In case this continues, I will escalate that to the management of the studies, okay? Because if there are 50 people taking the exam and only 5 to come to the lecture, then this is just not acceptable. Anyway, let's any question here? What? I don't understand the question. You can ask in German if you want. Wenn wir das jetzt machen, mit diesem? Jawohl. 3x3, ja. Gut. Okay, then we start a different topic, okay, called clustering, or specifically it's called K. Means clustering. Okay. This clustering algorithm, this is the easiest clustering algorithm. This clustering algorithm builds groups out of data. Okay. The hypothesis is that data are Euclidean. This means we can measure a distance between data points. What we mean with hypothesis is that this needs to be true in order for the algorithm to be implemented. If this is not true, we cannot implement the algorithm. Okay, let's look at something like intuitive as usual, just with a graphic. Okay. Our algorithm will be able to discern what are the groups here, group 1, 2, and 3 of these different clouds of points without any information additional, okay? We just need to tell the algorithm how many groups we're looking for. K, it's called K-means clustering. K is a parameter giving the number of groups. Okay? So the downside, the disadvantage of this algorithm is that we need to tell the algorithm how many groups we want. This is always a tricky question. Sometimes with hundreds of thousands of data, it's difficult. Okay, so this is the downside. The downside, let's do red. So the sunny side of it, we'll do it blue. The sunny side of it is that this algorithm is fast and furious. No, fast and efficient. Okay. Is very, very fast and efficient, which is something that is good when we need to make fast, strong decisions. Okay. So how does it look like? I mean, this is a little bit of, this is our first, if you want, first machine learning. We will look at more machine learning algorithms we will do here. And yeah, so it's kind of fun. You'll learn a little bit of algorithms, machine learning algorithms, and I mean, not only business crap. So K means algorithm. Goes in different steps. So step 1, or better said, step 0. Okay, before we start, we decide the number of clusters. So we decide K. Okay, this you need to do. This is so-called expert decision making. Okay, so this is your first step. Like walking with a shoe. Okay. But this is given to you in the exam, so you shouldn't care much. I just tell you, okay, now imagine you're looking for 3 or 4 or whatever number of warehouses or factories or whatever group or customers or something like that. So step 2. Step 1, sorry. Step 1. You need to distribute the data points in K groups. So that's cool. You distribute whatever data points you have in 1, 2, 3, 4, 5 groups. Another step. Step number 2. Of course, we will do an example right away. So the step number 2 is to find the so-called centroid, which is nothing but the center of mass or the mean, Mittelwert, okay, of each group. Super easy, is easier than as easy as calculating the Mittelwert, okay, the mean value. So step number 3. Calculate the distance of all the points to all centroids. Okay? And step number 4. Cluster the points. Cluster means create groups. Cluster the points by their distance to the centroids. All right. Once this is done, one first time, then we say we need to repeat from step 1 to step 4. Okay. The step number 5 is repeat from step 1 until the centroids are constant. Okay. If you don't repeat, you don't get points, okay, in the exam. If I ask this and you don't corroborate that your centers do not change, then you haven't closed the algorithm and you have not done the exercise correctly. I hope I make my point in this very clear, okay? You need to close the algorithm and make sure that the points are, the centroids remain constant. Okay, so this is just a theory which is, I don't know, abstract and difficult to understand until we make an exercise. Once we do the exercise, you will see that it's quite easy actually. All right, so let's do a little exercise. Okay. We are given the location, and because we are given the location, we know we can calculate distances, so the hypothesis is given, is fulfilled, of 5 factories. Okay? Find out the best position of 2, so K is 2, of 2 warehouses that ought to deliver these factories. Okay? So the position of the factories are of course, we want the warehouses to be as close as possible so that we have minimum transport, okay? The position of the factories are x coordinate 0, 6, 1, 7, 2. Y coordinate 3, 1, 2, 0, 4. And the factories are A, B, C, D, E, okay? So if we paint this in a little graphic, okay? So this is just for explanatory purposes. Our factories are located in the map like this. 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, and 4. So 0, 3, this is our first factory. A 6, 1 is going to be here. 1, 2 is going to be here. 7, 0 is going to be here, and 2, 4 is going to be here. Okay, so intuitively, what we got is two groups. So somewhere but this is just intuition, okay? You need to do it. Somewhere our first warehouse will be there. Our second warehouse will be somewhere here, okay? Does it make sense? But this is just intuition. So the first step, or step 0, following the algorithm above, is to decide, okay, because we are looking for 2 warehouses, K is 2. Okay. Then if nobody says otherwise, I choose 2 groups. So group 1 is going to be factory A, B, C, and group 2 is going to be D and E. Okay. Good. Then the third step is to calculate the centroids. So the centroid number 1 for group 1 is going to have coordinates 0 plus 6 plus 1 divided by 3 in the x-axis, and 3 plus 1 plus 2 divided by 3. So it's going to be 3.5, 2. This is our first centroid, okay? No, sorry, 2.33. The second centroid for group 2, I take the x coordinate of D and E, 7 plus 2 divided by 2, and then 0 plus 4 divided by 2. So it's now, yes, 3.5, 2. No, 4.5. I don't know why I have this 3.5 in my mind. So 4.5 divided by 2. Okay, so this is just calculating the centroids, the center of mass. Now step 3, distances. Okay, so we want to calculate the distances. So the distance of factory A to centroid 1 is the x coordinate coordinate of point A minus 2.33 square plus y coordinate 3 minus 2 square. This equals 2.53. The distance of point A to centroid 2 equals 0 minus 4.5 square plus 2 minus 2 square. This equals 4.5. Okay. Sorry, no, 3 minus 2. 3 minus 2, which will deliver 4.6 something, 6.1 or something. All right, so the distance to the first group from A is smaller, so A belongs to the first group. Okay, let's do the rest of the points. Point B, it's at Z1, as following coordinates: 6 minus 2.33 square plus 1 minus 2 square. This is 3.8. The distance between B at Z2 is 6 minus 4.5 square plus 1 minus 2 square. This equals 1.8. So B belongs to the second group because 1.8 is smaller than 3.8. The distance between C and Z1 is again 1 minus 2.33 square plus 2 minus 2 square. So this delivers 1.33, right? This is straight. Then Z to Z2 equals 1 minus 4.5 square plus 2 minus 2 square. So this is going to be 3.5. So Z is going to belong to the first group. Then we go with D. Then we have 7 minus 2.33 square plus 0 minus 2 square. This delivers 5.08. And the distance between D and Z2 is 7 minus 4.5 square plus 0 minus 2 square, 3.2. So D belongs to the second group. And then again, E is going to belong to the first group. I guess this is going to be 2, 4. So 2 minus 233 square plus 4 minus 2 square. This yields 0.2, and then dE to Z2 equals 2 minus 4.5 square plus 4 minus 2 square is bigger, 3.2. So E belongs to the first group. So now here we just finished the first step 1 to 4. Okay, so now we need to go back because our new groups new clusters are group 1 star is A, C, and E. Okay, this, which is not what we saw in the beginning. And then the second group star is B and E. Okay, which is not what we saw in the beginning. So we need to start again. All right. So we start again. Our new centroids. Z1 star. We need to take A, Z, and E. So the coordinates are 0, 1, and 2. Divided by 3, and then epsilon 3, 2, and 4. So this yields 1, 5, 9, 1, 3. Okay, and the second coordinate is coordinates by B and E. Sorry, this is D. It's not E, it's D. We cannot have a point in two groups. B and D is 6, 7, 1, 0. So 6, 7. So this is going to be 6, 5, and 0, 5. Is that cool? So we have our new centroids. Now we calculate our new distances. Cool. Then distance from A to the new centroid. Square root of 0 minus 1 square plus 3 minus 3 square is going to be 1. This is going to be smaller than the distance between A and Z2 square, which is 0 minus 6.5 square plus 3 minus 0.5 square. You can do it. It's going to be smaller, so this belongs to this group, which is good because it's what we were looking for. So the distance between the second point of first group, Z, to the center 1 star is 1 minus 1 square plus 2 minus 3 square. This is going to be again 1. This is going to be smaller than the distance to the second thing. 1 minus 6.5 square plus 2 minus 0.5 square. Okay, so again, we are on the right side, on the sunny side, and then the last point will be again smaller. We do it 2 minus 1 square plus 4 minus 3 square. This is going to be square root of 2. This is again smaller than the distance between E and Z2 square, which is way bigger. 2 minus 6.5 square plus 4 minus 0.5 square. Okay, so this is again smaller, so we're cool. The first group is confirmed. Then let's look at the other one, Z1 star and B, which B is 6 and 1, so 6 minus 1 square plus 1 minus 3 square. This is 25 plus 4 is square root of 29. This is bigger than the distance between B and Z2 square, which is 6 minus 6.5 square plus 1 minus 0.5 square. Okay, so this belongs to this group. And then d to z1 is 7, 0, right? So 7 plus 0 minus 3 square is 36, 6. This is way bigger than d to z sud square, which is 7 minus 6.5 square plus 0 minus 0.5 square. So this belongs again to the second group. We're cool. Group remain constant, and we can close the algorithm. So the real groups are G1, A, C, and E, and G2, B, and D. Our warehouses, warehouse 1 is located at 1, 3. Warehouse 2 is located at 6.5, 0.5. Just like we saw here in our intuition, was not so bad. 1, 3, okay. So this is the point 1, 3, and this is the point 6.5, 0.5. All right. Any questions? I don't get your question. Can you repeat it, please? Restate it. I don't understand. Yeah. No. In the exam, I would tell you which with groups you start, because I want to test that you know the algorithm. So I will not tell you start with A, C, and E, and then B and D, because then we don't test anything. Okay. I will give you the initial groups. Yeah, I would give you if I ask this. Yeah, no problem. Any questions? Any more questions? So this was one question in the exam last year or last semester. Of course, with different numbers, but I totally recommend that you give yourself new numbers, okay? And try this on your own. Okay? So I give you one exercise to do by yourselves, which I will not solve. So the position of 7 factories with, now this is the difficult part, with different demands. So you need to be here, just a little help. You need to use weighted mean calculation, okay? With different demands on raw material. Is given by their coordinates x, y. Okay, every factory is delivered by one of two warehouses. Okay. To reduce the transport cost, the suppliers ask you to perform an analysis and recommend the optimal position of their supply points. Okay. So now the data is x coordinate, a vector 1, 2, 0, 6, 7, and 3. Another vector 3, 2, 1, 1, 2, and 3. And the demand to 1, 3, 1, 3, 1. Okay. As I said, yeah. Yeah, 6 factories, whatever. Doesn't matter. Thank you. Yeah, so start with groups A, B, C, D, E, F. Okay. Group 1, A, B, C. Group 2, D, E, F. Okay. And the hint, as I said, the centroid of 1, okay, A, B, C, is calculated like this. It's a weighted mean value, so it's 1 times 2. Okay, this comes from 1 times 2. It's weighted, okay? with the demand plus 2 times 1, again 2 times 1 plus 0.0 times 3 divided by 3. Okay. And then 3 times 2 plus 2 times 1 plus 1 times 3 divided by 3. All right. Just a hint. I will not solve this problem. Blinker, okay? I don't know how to say it. I will not solve it. All right. So today we saw deep learning convolution, and we saw k-means clustering. In last year's exam, in the summer semester, these two exercises were 40 points out of 100. Okay. So just with today's lecture, you would have like 40 points in that exam. All right. Any questions?